Hey guys, today we're going to go ahead and go back in topic 4. We're going to go back to the beginning and just make sure that you're solid and ready to go. So we're going to be starting with 4-1, solving systems of equations by graphing. So topic 1, you learned how to solve equations and inequalities. In topic 2, you learned about linear equations, meaning when you had an equation and you solved it, then you could graph it. In topic 3, you had linear and absolute value functions. Topic 4 is all about systems of linear equations and inequalities. Let me go ahead and share my screen. Okay, so we're going to be learning about solving systems of equations by graphing. So by the end of this unit, you're going to be able to use graphs to find approximate solutions to systems of equations. So something I want to remind you is when we are solving systems of equations, we have to remember that y equals mx plus b, that slope-intercept form equals mx plus b, where b is known as your y-intercept and m is your slope. And slope is always written as rise over run. So essentially what we're going to be doing is we're going to be taking two equations, writing it in slope-intercept form, and then we are going to graph it to see if there's a solution. So we're going to take those two equations, and if they intersect, it's one solution. If they don't intersect, it's no solution. If they're the same line, it's infinite solutions. So as we're working through these problems, I want you to keep that in mind. Let's go ahead and look at our first problem. Okay. So it's solve a system of equation by graphing. So we have two different equations. We have y equals negative 2x minus 4 and y equals 5/10 x plus 6. And they went ahead and they graphed it for us. So I just want to bring some things to your attention. So what they did is they went down to negative 4 and then they graphed it that negative 2. So we know that this slope would be negative 2 over negative 1 or 2 over 1. So if I'm down here at negative 4 and I went up 2 over 1, up 2 over 1, up 2 over 1, this would be my line here. And then this equation right here, y equals negative 5/10 x plus 6, they would go over here to 6. That is your b, your y-intercept. And then our slope is 5/10 over 1 or negative 5/10 over negative 1. So if I went here to 6, and I would go down half over 1, down half over 1, down half over 1. And these two lines, these two equations are going to intersect at negative 4, 4. So after we graphed both equations, because it's in that y equals mx plus b format, we saw that they intersected at negative 4, 4. So these lines have one solution. They intersect, they cross at one point. There's no other points they're going to cross because they are a line. So now that we have our point, we're going to plug in this point, x and y, into both equations to see if it's true, to see if that solution works. So because we can't really see it, y equals negative 2x minus 4. And then we have y equals 5/10 x plus 6. And we're going to plug in the point, which is negative 4, 4. So I'm going to go 4 equals negative 2 times negative 4 minus 4. And when I solve that, because remember, this equal sign just means that this side of the equation equals this side of the equation. I'm left with 8 minus 4 equals 4. 8 minus 4 is 4. Does 4 equal 4? Yes. And same thing over here. I'm going to plug in the solution we found when we graph these two equations. I've got 4 equals 5/10 times negative 4 plus 6. When I solve this, this equals negative 2 plus 6. Negative 2 plus 6 is 4. Does 4 equal 4? Yes. So there's one solution, and that is negative 4, 4. Let's take a look at another example. So I am going to look at example A, y equals 1/2 x minus 2, and y equals 3x minus 7. Okay, I'm going to solve this by graphing to see what the solution is. What is the coordinate point? Okay, they're both written in slope-intercept form, so that takes a little bit of the work away. Y equals negative 1/2 x minus 2, and y equals 3x minus 7. Okay. So my y-intercept for this one is -2. I start at my origin and I go down to 2. And then my slope is 1/2. So I'm going to rise 1 over 2. Rise 1 over 2. Rise 1 over 2. And then I can actually go opposite. I can go down 1 over -2, down 1 over -2. And I just created my line for my 1/2 x minus 2 equation. And now I'm also going to graph this one. I'm going to start at my B, my y-intercept, which is 7. 1, 2, 3, 4, 5, 6, 7. And it's 3x is my slope. So that's 3 over 1. So up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. You should already say, there's our answer. Up 3, 1, 2, 3 over 1. But we're going to keep going. Up 3, 1, 2, 3 over 1. And then when I play connect the dots, I see that there is one solution, and that is 2. It is 2, -1. So my solution is 2, -1, but I have to check it. So I found when I graphed this equation, it was 2, -1. And I can plug in this ordered pair into these equations to see if it is true. -1 equals 1/2 times 2 minus 2. And then my other equation would be -1 equals 3 times 2 minus 7. Remember, this equal sign just means that this side of the equation has to match this side of the equation. So 1/2 times 2 is 1, and 1 minus 2 is -1. So it satisfies this equation, and then we're going to solve this. -1 equals 6 minus 7. 6 minus 7 is -1. -1 equals -1. These two equations have one solution. Let's look at example 2. So in example 1, we learned when two equations have one solution. Now there are 2 other options. When you graph something, it can have infinitely many solutions, meaning that it's essentially the same line, or it could have no solutions. So let's take a look at these two equations. What you should notice automatically is one is not written in slope-intercept form. So I always want to encourage you to write it in slope-intercept form. So if I'm trying to get it into that y equals mx plus b format, okay, I'm going to move the x over. And I'm left with 5y equals -15x plus 25. My y still isn't isolated, so I'm going to divide by 5 to cancel it here. But whatever I do to one side, I have to do to the other. So I'm going to divide by 5 with my other terms. And I'm left with -3x plus 5. Looking at that in my other equation, which is y equals 5 minus 3x, you can see that it's not in the y equals mx plus b format, so we just got to flip some stuff around. And would you look at that? They are the same exact line. So if I were to graph this line, and I were to graph, or excuse me, this equation and this equation, we would notice that the lines have the same y-intercept. They both intercept at 5. Their slope is -3. So the lines have the same y-intercept. The lines have the same slope, which is -3. Therefore, the graphs are the same line. So if both equations represent the same line, all ordered pairs on the line are solutions of both the equations, meaning that we could plug in this point in both these equations and it would make it true. We could plug in this point and it would make it true. So it has infinite number of solutions. Now, if we go ahead and look at this example, we learned when it had one solution, we learned when we had infinite solutions. So now we're going to look and see what it means if it has no solution. Looking at this example, that just means that the lines will never intercept. They are not the same line. They're never going to cross. They're never going to have an ordered pair that will satisfy both equations. So if we wanted to actually write this in a y equals slope intercept form, we could y minus 2x equals 6, negative 4x plus 2y equals 8. And if we wrote it in slope intercept form, and then this would be 2y equals negative 4x plus 8 divided by 2. What is that? 8 divided by 2, 4. And we went ahead and graphed that where this is 4 and the slope is down 2 over 1, down 2 over 1. And this one right here is 6. Notice these slopes, the lines are parallel. So there's no point of intersection. Therefore, there's no solution to this system of equations. You may think that the lines cannot be the same since the equations are different, because yes, they definitely are different. However, if you write both equations in the same form, meaning this y equals mx plus b, and divide the common factor, the equations are identical. Let's look at this example right here. So I have y equals 1/2 x plus 7. And then my other equation is 4x minus 8y equals 12. This is not in slope intercept form at all. Therefore, we need to write it in slope intercept form so that we can actually compare them. Okay, so I need to isolate the y. I'm going to move this over. Whatever I do to one side of my equation, I have to do to the other. And now I'm left with negative 8y equals negative 4x plus 12. Divide by negative 8. Divide by negative 8. And we're left with y equals negative 4 over negative 8x plus 12 over negative 8. I hope that when you're looking at this, you instantly see, oh, 4 over 8, that's the same thing as 1/2. Let's bring our other equation down and see what you notice. Looking at these two equations, they have the same slope. So if we were to graph them, just for fun, my y-intercept would be 7. Let's say that this intercept is for, just to throw it out there, let's do 12 divided by 8. Oh, I don't know. Fine, let's just throw it out there and just say it's 4. And I always went up 1 over 2, up 1 over 2, up 1 over 2, and same here. We're going to get 2 parallel lines. And it's not going to be perfect. But I have 2 parallel lines. These lines are never going to intercept because they have the same slope. Therefore, there is no solution. Okay. Let's look at example 3. Monisha and Holly have 14 more days to finish reading the same novel for class. Monisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. Assuming Holly and Monisha both maintain their reading plan, when will Holly catch up with Monisha? Who will finish reading the novel first? This is taking what we just learned about systems of equations and applying it to a real world example, right? So we're trying to figure out total pages. There's 96 pages already read. She's doing 9 pages a day for X amount of days. So that's why we have this y equals 96 plus 9x, meaning she already started on page 96. 14 more days to finish. Okay. So we need to write a system of equations represent the reading pages. And it tells you how many pages. That's where they got the 96. Oh my goodness. Page 96 out of 220, and this is page 6 out of 220. So they both have to read 220 pages. So we have y equals 96 because that's your starting point, and she's reading 9 pages a day. Okay, Holly has only read 6 pages, and she plans to read 20 pages a day. Who will finish reading the novel first? Okay, and that is where we're going to use our systems of equations. Okay, so let's go ahead and set this up We have to find where the graph is going to intersect. I don't like this. So fun. Okay. Y equals 9x plus 96. And then y equals 20x plus 6. Okay, we're back. Okay, so when we went ahead and we wrote the information in y equals mx plus b format, and we graphed it, we see that it intersects here at 8 and that. And that is our point. So that means that these two systems of equations has one solution. Absolutely one solution. So if we go back here to our next point, where we saw that they intersected at this point right here, after a little more of 8 days of reading, because remember our point was 8 and 182 thousandths and 169 and okay. So a little more than 8 days of reading, Monisha will have read 170 pages because we took this and we plugged it in to our systems of equation, which was y equals 9x plus 96. They plugged that in for x to solve how long it would take her to read. So now you guys are going to work on the Reteach to Build Understanding page and the additional practice page. When you are done with both sides, you're going to take a picture and you're going to upload it to Schoology.